So this is just a summary of what we've been talking about in class. So in class we looked at some pictures, some visual patterns, and we were able to go from a pattern to a table of values and then find an equation that would represent that pattern. And through that we started to talk about the difference between something that was linear and something that was not linear. So linear relationships occur when you're going up or down by the same thing. So if we look at this table of values, if we look at the x column, this is really important. We want to make sure that the x always goes up by 1. And when we look at the y column, we'll notice from 3 to 5, we went up by 2. 5 to 7, 2, 2, and 2. That's really important. As soon as we see that all the numbers are going up by the same thing, we know that the relationship is linear. And once we know a relationship is linear, we can come up with the equation. And linear equations have two pieces. And we looked at this when we were looking at our visual patterns. So the parts are what you go up or down by. And this one's a little bit trickier. This one, when we were looking at visual patterns, we talked about what would pattern picture number 0 look like. So this particular one is the value of your y when x is 0. And we'll talk a little bit more about that as we do work in this unit. So if we come back to this particular equation, let's see if we can build the equation. So we know that it's something x plus something. Well, what are we going up or down by every time? We're going up or down by 2, so we put that there. The next part is a little trickier. We have to figure out what the value of y is when x is 0. So if we go backwards in the table, 5, 4, 3, 2, 1, 0, and go backwards in the table, 11, 9, 7, 5, 3, 1, that is the value of y when x is 0. We could put that there. The other thing that we could do is we can test out a point. So we could say, what's 2 times 4? 2 times 4 is 8. The table says 9. We need to add 1. What's 2 times 5? 2 times 5 is 10. The table says 11. We need to add 1. So then we also looked at one particular visual pattern that didn't go up by the same thing every time, that we looked at square numbers. So if you look at this particular one, this forms a pattern, but it's not the same number every time. And because of that, we call it non-linear. So don't be fooled by a pattern. You need to make sure you're going up or down by the same number every time. And non-linear equations can be all kinds of different things. They usually have a degree. They have exponents. So things like x squared, x cubed. You're not going to be asked to find non-linear equations. You're only going to be asked to find linear ones, but you should know the difference between something that's linear and something that's non-linear. This particular slide here that we talked about in class is essentially just a really fancy word for something that you've actually been doing quite well. It's a fancy word for figuring out what your y's are going up or down by. So in this case, our y's are going up by 2 every time. That means that our first difference is 2. If our y's are not going up by the same thing, then we know that if the first differences are not the same, that we know the relationship is non-linear. So now if we come back to here, we can add a new term. This number is what you're going up or down by, but it's also the first difference. So again, just a fancy word for something you've already been doing. So the last thing that we looked at was some tables, and we looked at trying to figure out if they were linear or not. So for example, if we look, first thing again, we want to double check, are the x's going up by 1? And in all of these cases, the x's are different, but they are all going up by 1. Then we look at what are the y's going up, or down by. So in this case, every time we're going down by 4. That means it's linear. In this case, we're going down by 1, then up by 1, then up by 3. Not the same number, it's nonlinear. Here, we're going up by 2 every time, it's linear. Here, we're going down by 2 every time, still linear. Here, we're going up by 3 every time, linear. Here we're going up by 1, up by 2, up by 3. It's a pattern, but it's not the same number, so it's non-linear. This next one, we're going up by 3 every time. And this one, we're going down by 3 every time. So both of those are linear. So then it says, if it's linear, what's the equation? So let's come back to the first one. We know that our equation will be y equals negative 4x, because it was going down by 4. Then we find our 0, and we can say plus 7. This one, y equals 2x, because we're going up by 2 every time. We find our 0, and we can say plus 2. This one's a little bit harder. So we know that it'll be y equals negative 2x, but it doesn't give us a 0. So we have a couple of options. We can figure out the 0 by working our way through the table. So the next point would be negative 1, 0. And then the next point would be 0, negative 2. And we can do that. Or we can test out a point. For example, what's negative 2 times negative 5? Negative 2 times negative 5 is 10. But the table says 8. So how do we go from 10 to 8? We have to take away 2. So next one is going to be very similar. We know that we're going up by 3. So we know that it'll be y equals 3x. But again, it doesn't give us the 0. So we either can go 6, 5, 4, 3, 2, 1, 0 and go backwards in the table. So it would be 2 and negative 7. It would be 1 and negative 10. It would be 0 and negative 13. Or we can test a point. For example, what's 3 times 6? 3 times 6 is 18. The table says 5. How did we go from 18 to 5? We had to take away 13. If we look down at the bottom here, we're going up by 3 every time. Again, it doesn't give us the 0, but we could go 4, 3, 2, 1, 0. 12, 9, 6, 3, 0. In this case, the 0 will be 0, 0. So we could write plus 0, but we tend to just write y equals 3x. And then the last one, we're going down by 3 every time. And it does give us the 0. We can fill that in. So the basic idea here is that you know the difference between something that's linear and something that's nonlinear. So if I were to give you either a pattern or I were to give you a table, you could tell me whether the relationship was linear or nonlinear. And then the second piece is, if it were linear, you would be able to do this kind of thing here, where you would be able to tell me what the equation is. And that takes a little bit of practice, especially this one. This one's a little bit tricky to come up with. So ask for help if you need it. Now I just want to briefly show you one more. We're going to look at this one right here. If we look at this one right here, we're going to notice that our x's are not going up by 1 every time. So what we could do is we could rewrite the table and fill in the missing pieces. So we're given 0, negative 3, and 2, negative 1, and 4, 1, and 6, 3. We could fill in what's missing. And now we see, oh, okay, now our x's are going up by 1. And we can see, oh, look, our y's are going up by 1. So our differences in our y's are going up by 1. So now we can make the equation y equals 1x, or x, and then we find our 0 minus 3, and we can come up with the equation.